Welcome friends to my channel. Now yesterday's lecture I have told about linear and angular momentum conservation theorems and I also told about homogeneity and isotropy. Okay. Now in today's lecture I shall going to discuss few another issues, that is, first of all I have showed that homogeneity of space leads to the conservation of linear momentum, and today I shall going to show that linear momentum conservation can also be achieved by using Newton's law. Okay, so linear momentum conservation theorem by using Newton's law. Okay. Now if there are two particles, then we all know that the mutual force among these can be written in this way. Suppose this is particle number 1 and particle number 2. So we all know that F12 this equals to minus F21. What is F12? That we denote the force exerted by particle 1 on 2. Okay, and F21 this is the force exerted by particle 2 on 1. ঠিক আছে? Okay, so this is F12 means force exerted by the particle 1 on 2, and this is 2 1. We denote it that the force exerted by particle 2 on 1. So we have to use this. Okay, now so when one particle exists a force on 2, there will be a rate of change of momentum of the second particle. Okay, there will be a rate of change of momentum of the second particle, that means dp to dt. Okay, and when two particle exerts a force on 1, so there will be a rate of change of momentum of the particle 1. Okay, so we can write this. So clearly we can write this d dt of p1 plus p2, this is simply 0. So from which we can easily write p1 plus p2, this is constant. Okay, this is constant. And what is this? If mass is m1 and velocity is v1, so m for a two particle, this is constant. Okay. Okay, so we arrive at linear momentum conservation theorem by using Newton's law. Okay, so this is the force exerted by one particle on 2, so due to this there will be a rate of change of momentum of the particle 2, and similarly these things happens for first particle. So by using Newton's law we have arrived at the linear momentum conservation theorem. Okay, now or more generally we can write this linear momentum conservation theorem in this way, that is, if the initial and final velocities are of two particles, that is first particle is u1 and v1, this is the initial velocity of first particle and this is the final velocity of first particle, and if this is the initial velocity of the second particle and this is the final velocity of the second particle, so more commonly we can write m1 u1 plus m2 u2, this is equals to m1 v1 plus m2 v2. So this is the more general form. So we have arrived the linear momentum conservation theorem from uh, Newton's second law. Okay, so this is the first issue. Now on yesterday we have also discussed about the angular momentum conservation theorem. Now let us see what happens and what will be the angular momentum for a central force field. Okay, so angular momentum for central force field. Since central force is conservative, this we did in the past, so now again I am doing it. So angular momentum for a central force field. So central force field, that means this force can always be written in this way, magnitude into unit vector. Okay, so we can write L, this equals to R cross P. So what will be my dl dt? This is simply R cross dp dt plus dr dt cross P. Okay, so this is simply F, and this is simply V, and this is simply mv. So this term is 0. So this is what R means RR cap, and for central force field this can be written in this way. So R cap cross R cap is 0. So for a central force field, what we can write, that angular momentum of a particle remains constant. Okay, so this we did previously, that angular momentum for a central force field remains constant, or if a particle lie in a central force field, then its angular momentum is conserved. So this is the justification. Okay, so this is the angular momentum for a central force field. Okay, now let us do a numerical. Okay, so let us do a numerical problem. Okay, the numerical problem is given that R, this is equals to I cap A cos omega t plus j cap B sin omega t. Okay, where A, B are constants. Okay, A and B are constants. So we have to show that L acts along z direction and it is constant. It is constant. Okay, we take okay, and it is constant. So given that R is this, so what will be the velocity dr dt? That is minus I cap A omega sin omega t plus j b cap omega cos omega t. Okay, so this is the case. Now what will be the angular momentum? This is simply R cross P, that means R cross mv, that means V means dr dt. Okay, so simply if we do R cross dr dt, then this cross this will be 0, and I cross j means k. So k cap A B omega cos square omega t, j cross I, that means minus k, minus a plus k, and this is 0. So k cap A B omega, this is sin square omega t. So if you take k cap A B omega common, then this will be 1. So the result will be m A B omega into k cap. If you see the answer, first of all we have to show that angular momentum acts along z direction. So it is clear there is a k cap, that means plus z direction, and then we have to show it is constant. A and B, these are constant, and angular velocity it is also constant, and mass is also constant. So we have arrived at the result that angular momentum is constant and acts along plus z directions. Okay, so this is a numerical. Fine. Now another numerical. So let's do another last numerical today. That is, given that this is given that f dot v, this is 0, we have to show that v square is constant, or you can say v is constant. How? Okay, Newton's law, we can write f, this is equals to m dv dt. So taking dot product by v, so f dot v, this is m v dot dv dt. This is given 0, and this can be written as d dt of half mv square. So obviously this term is constant. Say this constant is k. This is constant. So what will be my v square? This is simply 2k by m. K is constant and m is constant, so v square is constant. So this is also an simple numerical. Okay, so in our today's lecture we have discussed the linear momentum conservation theorem by using Newton's law, and we also do few numericals related to conservation theorem. Okay, now in my next lecture I shall going to discuss about the center of mass theory. Okay, so video link will be given in the description box, and if you have any query then just write it in comment section. So if you don't subscribe my channel then kindly subscribe it. Okay, thank you.